Today, on Orbital Mechanics and Astrodynamics Explained, we're going to be talking about thrusters. Thrusters are the devices used to accelerate our spacecraft using the thrust force. The parameters that govern a thruster are whether it is a chemical or electric thruster, what its ISP or specific impulse is, as well as its duty factor and scale factor. The ISP is the ratio of thrust to the weight flow rate of the propellant, and tells us how much thrust can be produced from a given amount of fuel. The duty cycle is the percentage that the thruster is on and active during a burn. The thrust scale factor can be adjusted based on how efficient the thruster is. This concept can be better understood using FreeFlyer, an industry-standard astrodynamics analysis tool. Here we have two spacecraft. Initially, they both have the same values associated with their thrusters. We can see that while performing a maneuver that changes the semi-major axis of their orbit, the semi-major axis for each of these two spacecraft remains the same. However, going into the equations that compute the thrust and the ISP for our new thrust spacecraft, we can increase the two primary coefficients for thrust and for ISP. Now, when we perform our burn maneuver for each of the two spacecraft, we can see that the semi-major axis associated with the new thrust is larger than the semi-major axis associated with the default thrust. Thank you for watching our Orbital Mechanics and Astrodynamics Explained series. Be sure to follow us on YouTube to learn more FreeFlyer and flight dynamics resources, and see the link in the description to download FreeFlyer today.